Good afternoon, 6th and 7th grade math. We are going to be moving into brand new chapters, and ironically, I believe it's actually going to be chapter 4 for both 6th and 7th grade, and it's all about fractions. So before we begin, what I want you to do is I want you to close your math books and your tablets so that you're not looking at the page and working ahead. You need to make sure that you have out a pencil and a sheet of paper so that you can take notes as well as work out these problems during this lesson. Alrighty, now, 7th graders, small note. We did skip several sections in chapter 3. That doesn't mean you're not going to do them. For instance, we skipped the hexadecimal section as well as the bases and working with bases. Because those lessons are a little bit more involved and a little too hard to describe just over video. They're not really good like that. They're not lessons that work well in that way. Or in that format. Mrs. Cassidy is going to teach it to you. Alrighty, so we're going to just go ahead and start a new chapter, and then we'll just come back for the basis. Alrighty? Now, so we have chapter 4, and it's all about fractions and mixed numbers. Alright, this is really simple. A lot of this is going to be review for you, and but that's a good thing. Review is always good. So, talking about terminology, we have the word numerator and denominator. Now, we know that the numerator is the top number, so let's say I had a 4, and the denominator is the bottom number. Let's pretend I had a 10. All right, same way if I had 7, right, over 3, 7/3. Those are both fractions. This is the numerator, denominator, 4/10, numerator, denominator. Alrighty, now, of course, the numerator, let's look at our example 4. And I'm just going to change it to make it a little bit smaller because I'm going to draw. Well, maybe I don't have to draw. Let's see if I can find my circle. I'll talk as I'm finding my circle. Ah, there we go. Alright, so the fraction 4/6, what does that tell us? Well, the numerator, this top number, tells us how many parts are considered, and the denominator tells us how much or how many slices. I like to think of a circle when I think of fractions. So I always say slices, but how many parts are in the entire object. So for instance, I have this lovely, gorgeous circle. So I'm going to cut this circle into 6 parts. So let's see, let's not make a mistake. 1, 2, 3, 4. Then we make 8. So we need to do it this way. I know, isn't it wonderful when you get to draw in math class? Now this is not perfect. 1, 2, 3, 4, 5, 6. Bam, got it. All right. So I have 6 parts, but I only need to take into account 4 of them, which means I'm going to shade 4 of them. Let's get a little fancy. Let's use some crayons, right? So 1, oh, that's ugly. 2, but it'll do. 3, and 4, okay? Now, of course, if this was if this was a good drawing, each of these slices or each of these parts would be even. As you can tell, this guy's a little bit bigger. But that's okay for demonstration purposes. Alrighty, so like I said, the top number tells you how many to consider out of the whole object. Alrighty, let's see. Now, a proper fraction is a fraction whose numerator is less than the denominator. Alright, so for instance, 10 over 20. This guy is less than 20. Or if I have 4 over 7. 4 is less than 7. Something that is not a proper fraction is if, for instance, let's say I had 10 over 9. 10 is greater than 9. That is not a proper fraction. Now, if we have a fraction that is not proper, we call it improper. And that is, of course, where the fraction is where the numerator is either equal to or greater than the denominator. So 10 over 9 would be considered improper. 7 over 6 would be improper. And also 4 over 4. Notice, it says, because remember, it says the numerator is equal to. It can also be equal to. So 4 over 4, 3 over 3. Now, of course, if we have the ones that are equal to, what do they always equal? They always equal 1. Alright, because I like to think of it, let's say I ate 3 slices out of a pizza with only 3 slices. Well, how much of the pizza did I eat? Well, I ate the whole thing. I ate 1 whole pizza. Or if I ate 4 slices out of a pizza with only 4 slices, I ate 1 whole pizza. Okay? Nothing left. So that's proper and improper. Now, one thing to note about proper and improper is that there is a way to take these fractions and change them so that, especially with the improper fractions, we can change it into what we call a mixed number. Alrighty, whenever we have an improper fraction, we can change it to a mixed number. And it's not quite, it becomes, what it happens is you take it from this improper phase and you make it more presentable, I like to think of it. So for instance, if I had 10, there we go, 10 ninths, all I would do is take this. Now remember, this line right here is a division. It's a fraction bar, but it also means to divide by. So I can say that 10 ninths is the same as saying 10 divided by 9, which means that I can actually just set this up, right? 9, 10, work it out. How many times is 9 going to 10? Good, that's once. 10 minus 9 once. Write my remainder as a fraction. And I know that 10 ninths, let me rewrite it, 10 ninths is the same as saying 1 and 1 ninth. This is what we call a mixed fraction. It's mixed because it has a whole number and a fraction. Mixed fraction. Alrighty? So that's something fancy and awesome we can do with an improper fraction. Let's see. Now I already just discussed this with you. So if we have a fraction, that fraction bar is the same as saying division, which means we could take it and throw it in to a division symbol or a division symbol like this. Okay? Same thing we just did. And of course we use that to change improper to mixed. Now here's an example. Let's look at it. Of course it gives you kind of the answer, but that's okay. It says to write each quotient as a fraction and each fraction as a quotient, and then simplify to a whole number if possible. Now notice it says 2 divided by 5. Well, this first number is your numerator, and this last number is your denominator. There you go. And we just write it as a fraction. Now, can we simplify this to a whole number? No, because 2/5 is less than a whole, so it can stay a fraction. Alrighty. Here's another example. Same example. It says write each quotient as a fraction and each fraction as a quotient, and then simplify to a whole number if possible. Now notice we have 6/3. Alright, 6/3 is the same as saying 6 divided by 3. And then we work that out. Now, of course, we don't need to set it up like this, right? If you remember your division facts, got a little spasm going there. There we go. If you remember your division facts, you know already that 3 goes into 6 2 times and you don't need to work it out. But if you do need to, well, you shouldn't at this point, but if you do, that's what we're basically doing. Now, 6 divided by 3 gives us 2. So notice, in that case, we were able to simplify this fraction to a whole number. Alrighty. Now, here's another guy. Oh, gorgeous one. Same directions. We have the fraction, or we have the division problem, 4 divided by 4. Well, 4 divided by 4 is the same as saying 4 over 4, or 4/4. And I already told you that if your numerator and your denominator are equal, they equal 1. Alright, so now let's do this. This is the easy one. It says, write a fraction for the shaded part. Well, the fraction, notice that we have 5 sections. 1, 2, 3, 4, 5. So we put a 5 as the denominator. 2 of them are shaded, so 2 is our numerator. Okay, so that's really simple. Alright, so now let's check out this next skill check. It tells us to write a fraction for this shaded part. Well, how many parts, or how many triangles in this case do I have? 1, 2, 3, 4, 5, 6, 7. So when I set up my fraction, I have a denominator of 7 because that's the total. Now, how many are shaded? 1, 2, 3, 4. So my fraction is 4/7. Alright, now look at this one. How many little slots, or how many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. And how many are shaded? 1, 2, 3, 4, 5. So 5/9. Okay? So this is really simple, isn't it? Now let's move on to something not much harder. Now we need to write an equation, or excuse me, write each quotient as a fraction or a whole number. Alright, so I have 6 divided by 13. Now remember what I told you. This guy is your numerator, n. This guy is your denominator. So we say 6/13. Alrighty, now on this one we have 15 divided by 8. Or excuse me, 8 divided by 15. Okay. Now it's the reverse. When you use this fraction bar symbol, or this fraction symbol right here, not fraction, excuse me, when you use this division bar symbol, in this case the inside number, your dividend, is your numerator, and your divisor is your denominator. So what you have is 8, oops, there we go, 8/15. Alright, so see how it changes up for you? There we go. 8, there we go. Little technical difficulties, but nothing that's going to stop us. 15th. There we go. 8/15. Alright, so that's pretty simple, isn't it? Now, let's move on to our very last part, and I think we can skip ahead of this. Now, when we have these lovely, gorgeous fractions, for instance, if I had 10/20ths, right, 10/20ths. In this case, I could take this fraction and I can actually reduce it, meaning write it into its lowest terms, okay? So a fraction is in its lowest terms when the greatest common factor of the numerator and the denominator is 1. So basically, it's fancy terms for, in this case, taking this fraction and writing it in the smallest form it can be written. Alright, so how do I reduce a fraction? Well, I use the greatest common factor. Really simple. Now, greatest common factor, this is a definition. You do want this. You do want this. It's when two or more composite numbers have a factor or factors that are the same. Each shared factor is called a common factor. And of course, if we're dealing with greatest, we want to pick the largest common factor. Alrighty, so the greatest common factor is the greatest, meaning the largest factor, common to these numbers. Now, one way of finding the greatest common factor is to simply list the factors of each number. Alright, so this is really simple, and you've done this before. So let's say that I have this fraction of 10, that's right, 10/20. So with 10/20, what I need to do is to first write the factors of 10. So what are the factors of 10? Well, I like to start with the number 1. That's the easiest, so I don't forget him. And I might have to type it, because I think my poor computer's getting tired. 1 times, yeah, alright, we're just going to type this. Alright, so what are my factors of 10? Well, my factors of 10 are 1 times 10. What else? We have 2 times 5. Are there any other factors? Any 3s, any 4s? Well, we already have the 5s, so that's it. Alrighty, so what are the factors of 20? Well, we have 1 times 20. We have 2 times 10. Do we have any 3s? Any 4s? Yeah, we got a 4. 4 times 5. Of course, you know what I forgot. I forgot my commas. Separate those. Alrighty, any other factors that I might be missing? Any 5? Well, we already got the 5s. Any 6s? Any 7s? No. That's it. And we already have our 10. So now, what factors do they have in common? Well, here we go. They both have a 1, but we're not really going to count a 1. He doesn't really do anything. Oh, I see a 2. There we go. We got a 2. And a 2. We have a 10. A 10 and a 10. What else do we have? We have a 5 and a 5. Alright, so here's the big question. Which one of those numbers that they have in common? Okay. Which one of those numbers that they have in common is the greatest? Is the 2 the greatest? The 5 is the greatest? Or the 10 is the greatest? Well, the obvious answer would be 10. 10 is your GCF, meaning your greatest common factor. That means I can divide. Now I can divide this guy. Let's move all this out the way. Okay, let's move all this out the way. Slide him down. That means I can divide my numerator and my denominator by 10. All right, I can divide it by 10. So let's go ahead and do that. So I'm going to divide it by 10 and then divide this guy by 10. All right, so here comes the question. What is 10 divided by 10? Well, exactly. That gives you 1. Alrighty, and then what is 20 divided by 10? Exactly. That gives you the gorgeous, the wonderful 10. Alright, so you have a fraction of 1/10. Alrighty, so 10 over 20, or 10/20 is reduced to 1/10 simply by finding the greatest common factor. Alrighty, now this is what I want you to do. Let's see, and this one just shows you the exact same thing. 21 over 35, when we reduce it, we divide it both by 7 because that is the greatest common factor, and we get the fraction of 3/5. Alright, now 6th graders, your lesson for today just pertains to the greatest common factor. So what I want you to go ahead and do is to open up your books to the assigned page and begin working out all of those problems. Alrighty. 7th graders, your work, let's see, I believe that is all that we have to do. Exactly. So those were just some sample problems that I was flipping through, where it tells you to write it in lowest terms. But you're going to practice that anyway by working it out. So what I want you to go ahead and do is open up your tablet or your book and begin working on the assigned pages. I will have another video for you next time, hopefully without the glitches. I'll figure out what that's all about, but I shall see you again. Alrighty, or I shall say I shall talk to you again. Alrighty, have a wonderful afternoon.